Hello and good evening, Cisco Networking Academy instructors taking the Python Programmability Initiative course. In this very short video tutorial, we're going to be circling back to talk about implicit and explicit type conversion. In other words, the way that Python can either implicitly or explicitly take one data type and cast it or convert it into another data type in order to perform an operation. So let's take a quick look at how this might get done. So first, we're going to talk about implicit type conversion. And again, with implicit type conversion, this is where Python can promote or convert a lower data type, such as an integer, to a higher data type, like a float. Now, we say that the float is the higher data type because it's more precise, and it can give us more precision because it has that decimal inside of the number. And so that would be considered a higher data type, whereas an integer, we may lose some precision and granularity because we don't have the decimal place in that number. So here's what an example of that might look like. First, I'm going to create two variables. The first one will be called myInt, and we'll set that to 99. And then we'll call the next one myFloat, and we'll make that 3.14. Now, the reason that we say that this is implicit type conversion, what you're about to see, is that we are not explicitly telling Python to convert one data type to another. Python is going to take care of this auto-magically behind the scenes for us. So what might this look like? Well, first, let's confirm that myInt is in fact an integer. And as a reminder, think of classes like factories. And factories are producing objects. And so when we see class int, that simply means that myInt is an object that was created in the integer class factory. Now, let's also take a look to confirm that myFloat is in fact an object created in the class factory for floats. And that's what we have here. So we have an integer data type and we have a float data type. So what does Python do when I say myInt plus myFloat? It's going to give us back a float, 102.14. In fact, we can confirm this by rerunning the previous operation and assigning the result to this new variable called newFloat with a capital F. So if I was to say type newFloat, you would see that we've received a float. And so behind the scenes, implicitly, Python converted the integer to a float for the purposes of performing this addition operation. And you can see right here that in fact, we've received back a float. So that is implicit type conversion. The next type conversion that we're going to talk about is explicit type conversion. And the reason it's referred to as explicit type conversion is because we, the programmer, must explicitly tell Python, do type conversion here. And type conversion is also more commonly referred to as typecasting. In other words, we're casting one data type, and think of it like the movies. You're casting someone in a role. In other words, Brad Pitt is going to be playing somebody in a movie, and he's being cast in that role to play somebody else. And the same thing is true when we're doing explicit type conversion or typecasting by saying we're going to be taking one data type and we're going to cast it to play a role in our Python program as another data type. So how might we do this? A popular way to do this, and something that you might see, is when you're prompting users for information. Maybe we want to create a variable called myInteger that's going to capture user input. Maybe we're prompting the user to enter a number. Well, when we do this, let's go ahead and say input, please enter a number. Now, we're anticipating that the user is going to be entering in a number for us, and that Python is going to give us this response as an integer. However, when we say type, my int, you can see that what we receive back is a string. And by default, the input built-in Python function will return to you a string, even when you're asking for an integer or a float. It's going to return a string. And so a common way to deal with this is to simply enclose the input function inside of the integer function. And so what we're doing here, keeping in mind that we work from inside out, in other words, we're going to prompt the user first to enter a number. And then we are going to explicitly cast that response, which is the input from the user, from the keyboard, and we're going to cast it in the role of an integer. In fact, that's what we're going to receive back when we enter our new number in of 200, and then we say type in order to check to see what data type is my int, and we receive back an integer. And this is a common way of performing typecasting, is that we have to explicitly tell Python, I need you to convert one data type into another so that it plays a role in my Python program that allows me to get the feedback or the output that I'm looking for. Now, another way to do this, where we're doing explicit type conversion, might be in a print command. In other words, if I was to run the following print command and say, the value of my variable, and we'll do double quotes around my int, is, and you might be tempted here to simply go ahead and concatenate the string, the value of my variable, my int is, with my int. However, what we're going to see happen here is when I hit enter, we're going to receive a type error. Can only concatenate strings, not integers, to strings. In other words, what I typed in here was a string. However, remember, my int is an integer data type. And when we're using the plus sign to do the concatenation, we must have the same strings, or in other words, let me rephrase that. We must have strings. We cannot have a string and an integer because Python does not understand what it is we're trying to do when we're concatenating a string and an integer. So how might we overcome this? Well, we can pull back our previous print statement and I can cast this integer data type to play the role of a string inside of this print statement. And so I simply enclose my int into the string function, and now we receive back the output that we had anticipated. Now, one interesting side effect here is that the use of the string function and typecasting my int as a string in the print function is that we did not change the data type of my int. My int is still an integer. We simply cast that integer into the role of a string for the purposes of printing out our statement. All right, well, that is a description of both forms of type conversion. We looked at an implicit type conversion where Python did it for us, and then we saw two different forms of typecasting or explicit type conversion where you, the programmer, are responsible for telling Python, right here, I need you to cast this data type in the role of some other data type for use in my program. All right, thank you so much for watching. If you have any questions, please let me know. And looking forward to seeing everybody on Thursday evening. Have a great night.